Math Singer, yum!
In order to evaluate the integral of x cubed over the square root of 4 plus x squared by u-substitution, we can begin by recognizing that 4 plus x squared under the radical would be simplified with a single variable u. So letting u equal 4 plus x squared, du is then 2x dx. And then isolating dx by dividing both sides by 2x gives us that dx is equal to du over 2x. So now we're integrating x cubed over the square root of u times du over 2x. Well, x cubed over x is just x squared, and we can bring the 1/2 out front. So now we're integrating 1/2 times the integral of x squared over the square root of u du. And of course, our integral has to be all in terms of a single variable. So let's go back to our substitution and see that x squared can be isolated as u minus 4. So that brings us to a new integral of 1/2 times the integral of u minus 4 all over u to the 1/2 du, which by dividing u to the 1/2 by each term in the numerator gives us 1/2 times the integral u to the 1/2 minus 4u to the negative 1/2 du. Finally, we are at a position where we can begin actually integrating after having translated our original integral from a question in terms of x into a question in terms of u. Well, this is a relatively simple integral. We'll just write down the 1/2 and then grouping the rest of it, we have 2/3 u to the 3/2 is the integral of u to the 1/2, and the integral of 4u to the negative 1/2 is negative 8u to the 1/2. End the group and add our constant of integration. And we could stop there, but let's go ahead and multiply the 1/2 through both of the terms, giving us 1/3 u to the 3/2 minus 4u to the 1/2 plus c. Now, that looks like a final answer, except our original question was asked in terms of x, and we are at a position where we have an answer in terms of u. So we will go back to our substitution, seeing again that u was equal to 4 plus x squared, and we'll replace all of the u's with 4 plus x squared, giving us 1/3 times the quantity 4 plus x squared raised to the 3/2 minus 4 times 4 plus x squared to the 1/2 plus our constant of integration. And this would be a fine place to end the problem. If we wished, we have in fact found an antiderivative of x cubed over the square root of 4 plus x squared, and it's entirely in terms of x. However, we might recognize that there's a 4 plus x squared to the 1/2 as a factor of both of the terms in our answer. So we can factor 4 plus x squared, actually 4 plus x squared to the 1/2, out, leaving us, well, with the first factor, 1/3 times 4 plus x squared to the 2/2. Of course, 2/2 is just 1. And then we're left with just a minus 4 from the second term. And put in our constant of integration. And simplifying that a bit gives us quantity 4 plus x squared to the 1/2 power times the quantity, multiplying 1/3 through there, gives us 4/3 plus x squared over 3 minus 4, but I'm going to write 4 as 12/3 so that we can see that we can factor a 1/3 out of the second factor, giving us a final answer of 1/3 times the quantity 4 plus x squared to the 1/2 times x squared minus 8 plus our constant of integration. In order to integrate x cubed over the square root of 4 plus x squared dx by u-substitution, this time we're going to let u be the entire denominator, 4 plus x squared to the 1/2 power. Well, du then is going to be the derivative of that 1/2 times the quantity 4 plus x squared to the negative 1/2 power times 2x by the chain rule, dx. So isolating dx gives us the square root of 4 plus x squared all divided by x times du. Well, if we go back to our integral, we now have that the integral of x cubed over the square root of 4 plus x squared dx is equal to, well, x cubed over the square root of 4 plus x squared times, and then we'll replace dx with the expression that we found dx to be. That is the square root of 4 plus x squared divided by x du. Conveniently, the square root of 4 plus x squareds go away together, and we're left with x cubed over x. In other words, we've whittled this integral down to x squared du. Well, this leaves us with an integral in terms of two different variables. So we have just a little bit more work to do. But if we just go up to our substitution line where we let u be 4 plus x squared quantity to the 1/2 power, well, taking the square of both sides and subtracting 4 tells us that x squared is equal to u squared minus 4. So we have now transformed our original integral in terms of x into an integral in terms of u that is very easy to evaluate. The integral of u squared minus 4 du, well, that's equal to 1/3 u cubed minus 4u plus c. And if we're not careful, we're going to perhaps erroneously leave this as a final answer. We don't want to do that because the question that we were given was a question in terms of x, and the answer as we have it right now is in terms of u. We want the final answer to be in terms of the same variable in which the question was asked. Easy enough. We know that u is equal to quantity 4 plus x squared to the 1/2 power, so we'll just replace all of our u's with 4 plus x squared to the 1/2 power, leaving us an answer of 1/3 times the quantity 4 plus x squared to the 3/2 power minus 4 times 4 plus x squared to the 1/2 power plus c. This answer is perfectly fine to leave as a final answer, but if we wanted to go just a little bit further, we could recognize that 4 plus x squared to the 1/2 appears as a factor of both of the terms of our answer. And in order to make the final answer just a little bit nicer, we're going to factor out 1/3 times 4 plus x squared to the 1/2 power out of both terms. That leaves us with, well, from the first term, that leaves us with simply 4 plus x squared to the 2/2 power, in other words, 4 plus x squared, minus, well, and then the second term, we're factoring out the entire 4 plus x squared to the 1/2, but then we're also dividing 1/3 into 4, giving us 12. So 4 plus x squared minus 12 is the second factor, and that reduces to 1/3 times the quantity 4 plus x squared to the 1/2 power times x squared minus 8 plus our constant of integration.